Good morning, dear student. In previous lecture, we already discussed on the diamagnetic as well as paramagnetic material, the behavior of the diamagnetic and paramagnetic material in external magnetic field with graphical representation. So, in today's lecture, we are very much interested in the ferromagnetic material. So, if you consider this ferromagnetic material or ferromagnetism, when we think about when we think of magnetic material, that is the material which is act as a ferromagnetic material. When we think of magnetic material, the most common material that come into our mind are iron, nickel and magnetite. So whenever we think about ferromagnetic material, the most common material that come into our mind are made up of by iron, Fe, second nickel, and third, that is magnetite magnetites, iron, nickel and magnetite. They are generally called as ferromagnetic substances. So whatever the materials are made by iron, nickel and magnetite, they are called as ferromagnetic material, and they are called as ferromagnetic substances, not material. They are considered as ferromagnetic substances. They are called as ferromagnetic substances. If you consider this if you consider these ferromagnetic substances, in these substances there is a strong interaction of atomic magnets. So there is a strong interaction there is a strong interaction between atomic magnets. There is a strong interaction of atomic magnets, means the electrons, because the electrons is considered as a magnets, tiny magnets. So there is a strong interaction of atomic magnets, and these interaction forces are exchange type of forces. Third important point is that these interaction forces, so there is a strong interaction of atomic magnet. These interaction forces are exchange type of 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 forces and the interaction force between the atom. If you consider this ferromagnetic material, there is a strong interaction of atomic magnet. These interaction forces are exchange type of forces. These interaction forces are exchange type of forces. The interaction force between the atom, the next important point is that the interaction force between the atom is due to the exchange of electron. The interaction force between the atom is due to exchange of electrons. So whenever we consider a ferromagnetic material, then the material, it is made up of by iron, nickel, magnetite. They are considered as a ferromagnetic substances. There is a strong interaction of atomic magnets. These interaction forces are exchange type of forces. The interaction force between the atom the interaction force between the atom is due to the exchange of electrons. The exchange type of forces are very large and having a magnitude of 1000 Tesla. The next important point is that the exchange type of forces between the atoms, the exchange type of forces are very large. The exchange type of forces, the exchange type of forces are very large, are very large and having a having magnitude having magnitude magnitude. I will make a mistake here. Having a magnitude a magnitude of 1000 Tesla. So these exchange type of forces are very large, having magnitude of 1000 Tesla. Atomic magnets are aligned parallel to each other under the influence of these exchange forces. So this is very important. That is, atomic magnets. What happened due to the exchange type of forces? Due to this large exchange type of forces, these atomic magnets are aligned parallel to each other. Atomic magnets are aligned parallel to each other under the influence of these exchange forces. Under the influence of these exchange forces. So there is a strong interaction or strong interaction force between the atom, and this is due to the exchange of electrons, and the atomic magnets are aligned parallel to each other under the influence of these exchange forces. Under the influence of exchange forces, a spinning electron behave as a tiny magnet. So we already discussed the electrons is behave as a tiny magnet. In ferromagnetic material, the spin of two neighboring electrons are oriented in a such a way that strong interaction develop between the atoms containing these electrons. So if you consider electron behave as a tiny magnet in ferromagnetic material, the spin of two neighboring neighboring electrons are oriented. The spin of two neighboring electrons are oriented such a way that a strong interaction develop. The spin of two neighboring electrons are oriented such that a strong interaction is developed between the atoms containing this electron. A strong interaction develop between the atoms containing this electron. Containing this electron. This is a quantum mechanical effect, and that's the reason why these atomic magnets are aligned parallel to each other even in the absence of external magnetic field. So without external applied magnetic field, without application of external magnetic field, there is a parallel alignment of this electrons, and therefore these material are called as ferromagnetic material. So the net magnetization is very high as compared to the paramagnetic material, no doubt. So if you consider the ferromagnetic material, there is a strong interaction between atomic magnets, and these interactions are due to the exchange of electrons. The exchange of electrons are very fast. That's the atomic magnets are aligned parallel to each other under the influence of these exchange forces, and due to the exchange of electron, the spin of two neighboring electrons are oriented in a such a way that the strong interactions develop between the atoms containing these electrons, and this is known as quantum mechanical effect. And that's why this is the reason that why these atomic magnets are aligned parallel to each other even in the absence of external magnetic field. So there is no pairing of electrons. So without application of external magnetic field, there is a strong interaction that is between the two atoms having electrons, and the exchange of electron is very fast, that there is a no pairing of electrons, or we can say that there is a parallel alignment of these atomic magnets, and due to this the magnetization, the net magnetic moment is very much higher in case of ferromagnetic material as compared to the paramagnetic material. So if you consider, many times there is a confusion between paramagnetic and ferromagnetic material, that the paramagnetic material also have a unpaired electrons, and we know that they, due to this unpaired electron, they have a small net magnetic moment, but by the application of magnetic field, the electrons are aligned with the direction of applied magnetic field strength, and therefore they will shows the magnetization is increases in case of paramagnetic material. But if you consider this ferromagnetic material, this ferromagnetic material, there is a strong interaction between these atomic magnets, and these interactions are due to the exchange of electrons. And if you consider, the interaction is very fast, that the neighboring electrons are oriented in a such a way that a strong interaction is developed between the atoms containing these electrons, and there is a parallel alignment with each other. The atomic magnets are aligned parallel to each other under the influence of these exchange forces. So the exchange interactions, the exchange of electron is very fast, that the atomic magnets, the atoms are aligned parallel to each other. Atoms align parallel to each other under the influence of these exchange forces, and uh, there is a no requirement of external magnetic field for the parallel alignment, and therefore this material, in absence of external magnetic field, they shows net magnetization, they shows higher magnetization. So if you consider, in absence of external magnetic field or without application of external magnetic field, they will shows larger magnetization, and the net magnetic moment is very much higher in case of ferromagnetic material as compared to a diamagnetic material. So the magnitude of spontaneous magnetization is depends on the spin magnetic moment of spinning electrons. So whatever we consider, the net magnetization is very much higher, that the magnitude of spontaneous magnetization is depend on the spin magnetic moment of spinning electron. And the second point is that the measurable property corresponding to the spontaneous magnetization is also important. The magnitude of spontaneous magnetization depend on the spin magnetic moment of spinning electron. Second, the measurable property corresponding to the spontaneous magnetization is saturation magnetization. The saturation magnetization is the maximum induced magnetic moment that can be induced by the magnetic field. Beyond this field, there will be no further increase in the magnetization. So whatever the spontaneous magnetization and critical temperature, that is Curie temperature, we will discuss it in uh, next lecture, because up to this we are very much interested only in ferromagnetic material. So you should keep in mind what is ferromagnetic material. The materials are made up of by iron and nickel. They are called as ferromagnetic material. The exchange interaction, that is exchange of electrons between these atoms having a exchange force, and these exchange force results the atomic magnets align parallel to each other under the influence of these exchange forces, under the influence of this exchange of electrons. And due to this exchange of electrons. The spin of two neighboring electrons are oriented in such a way that the strong interaction is developed between the atoms containing these electrons, and the electrons are aligned. There is no pairing of electrons. The electrons are aligned. They are having same direction. So the electrons having a plus half spin, plus half spin in all atoms, and therefore the net magnetization is very much higher in case of ferromagnetic material. In the next lecture, we will discuss remaining point, that is what is spontaneous magnetization, Curie temperature, and the remaining, that is ferromagnetism and antiferromagnetism material. So this is all about the ferromagnetic material. In next lecture, we will discuss the ferrimagnetism and antiferromagnetism. Thank you.